Good morning, everyone. Welcome to the Theft Estimation Methodology webinar. If we could start off by making sure that you're all on mute if you're not speaking, and turning off your cameras as well, please. We do have a bit of background noise with us this morning. Thank you. So my name is Amy. I work on the communications team for the Rec Code Manager, and I will be facilitating today's session. I have joining me today colleagues from across the Rec Code Manager who are currently on screen at the moment. So just to take you through a few bits of housekeeping, this session is being recorded and the recording and slides for this event will be made available on the Rec portal next week. If everyone, again, could keep their microphones and cameras off and less speaking, it would be greatly appreciated. So to take your questions today, we're using Slido, and you can access this via the QR code that's currently on the screen. If you have a smartphone, you can scan this QR code to access Slido with your camera app, or you can type the number on screen into Slido in your web browser. Alternatively, if you're using the desktop app for Teams, you'll be able to see an S at the top of this call where you can also click and access Slido. We will have designated Q&A sections in today's session, but please feel free to raise your questions as they come to you throughout. So I will now pass over to my colleague JP to take us through the agenda for today. Thanks, JP.
Thanks, Amy. So for today's agenda, the presentation is going to be split into two separate sections. And like my colleague said, there's going to be some time for Q&A at the end of each. And we deliberately structured it this way to give you all the opportunity to drop off the call before the latter half of the presentation begins, which will go into more detail on the technical aspects of the theft estimation methodology. And we understand that not all of you may want this level of detail, so feel free to drop off before that begins. And so for the agenda, as we can see on the slide here, part one is going to give a background and a high-level overview of the theft estimation methodology. So really covering the fundamental principles of how it was developed from data gathering all the way to hypothesis testing before showing the estimated theft value that we have derived. This section is going to close off with next steps from the point of view of RECO and the Q&A. And like I said, part two will be a deep dive into the methodology, so covering topics such as decision trees, random forest algorithms, and multivariate analysis. So going more into detail on the technical aspects of the theft estimation methodology. And like I said, feel free to drop off before this part begins. So moving on, I'm going to pass it on to my colleague Roz.
Thank you, JP. So we can start with the background behind the theft estimation methodology, or TEM as it is known. So we move to the next page. Oh, here we go. Yes, so let's take a look at the background. On screen is the objective of the TEM project, which is essentially to establish a robust methodology to benchmark the volume of energy theft in Great Britain. It sounds like a rather short, simple objective, but it's challenging to achieve because we are trying to put a number on something that is unknown, and we want to do that in a robust, repeatable manner. So if we move to the next slide, we started with 3 planned estimation methodologies. We're going to approach it from 3 different views, essentially allowing us to home in on the volume of theft number by coming at it from different directions. The first methodology is depicted in the diagram at the top of the slide. We called this the whole system energy balance approach. So we know that energy goes into the system and that it should match the amount coming out. However, there's always a gap, and this is what we call unallocated or unidentified energy, depending on whether you're talking about gas or electricity. Energy that has been used but not allocated to a metering system, essentially. Some of this unallocated energy will be theft, but there are also various other sources, including things like metering errors and energization status errors. So under this methodology, we would be comparing the energy going into the total system against the energy leaving it, then analysing the gap between these two values to establish the sources of error and associated volumes to give a potential volume for theft with a confidence range. The second approach was the network-centric energy balance. This is an electricity-only methodology, as there isn't an equivalent level of metering for gas. but we know that DNOs are installing substation feeder meters, and under this methodology, we would take a sample of network sections with feeder meters and a high penetration of smart meters and analyse these to identify anomalies that might indicate theft. And then looking at these anomalies and other data sources such as confirmed thefts, deprivation data, build a picture of theft across GB. And then approach 3 was prior theft extrapolation, so characterising and segmenting confirmed thefts to extrapolate the likely volume of similar theft across the population. So if we move to our next slide, we reached out to parties across the energy industry to gather data to feed into these methodologies. For instance, we sought performance assurance data that would enable unallocated, unidentified energy to be allocated across the different sources of error. To give one example, is there metering audit data that would indicate the likelihood of metering system errors occurring, the associated volume and the direction of those errors. We also discussed obtaining half-hourly feeder meter data from distribution network operators alongside the downstream half-hourly meter readings for a selection of feeders. And we engaged directly with a number of suppliers to establish what data sets they held that could feed into the methodologies. This exercise established that the data available to us at present wouldn't be sufficient to take forward these methodologies, but it did establish that at a future point there may be the potential to bring additional data into the TEM, which I'll touch on in a later slide. But we did manage to obtain a large volume of data, and with that we developed a revised methodology to make optimum use of the data obtained. And I'll now hand over to my colleague Ursula to discuss this methodology.
Thanks, Ros. So we go on to the next slide, please. So in this section, I'll take you through kind of the summary of the methodology, so kind of where we're taken from the data gathering through the methodology that we were testing. We worked through some hypotheses and tested those with the data, and then kind of built up the final estimation. So if we go to the next slide, please. We'll start from when we started with the kind of the data that we did manage to access. So this included they identified the TRAS theft data. So this is kind of the confirmed thefts and the information around theft investigations. We also had data from ETOS, which was the that theft investigations that had the lead source from Crime Stoppers. And then we also had some post-TRAS confirmed thefts. That's kind of the investigations that were submitted for the incentive scheme post September 21. Across these, there was some duplication between the ETOS and the TRAS data, because one was the lead and the other one was the actual outcome of the investigation. So in addition to these, we identified that there were some further predictors that we might be able to look at, and this is through speaking with theft SMEs. So we identified some areas where there was kind of certain anecdotal evidence and suggestion that there might be data such as deprivation indices or housing type, crime data that might actually be useful predictors for theft. So we gathered these using official national statistics where we could, that we could then enrich the data set using the TRAS data, both the theft and the consumption data as a starting point. We then also had some additional data from Alexon and Xserve, which we had originally anticipated being able to kind of reconcile at low levels, but the granularity wasn't there. So we were then going to use that as a validation exercise kind of to map, to validate our theft estimates. To tie the data sets together, a lot of it was using spatial data, so we worked with the lowest level of data we could get. A lot of this was done at LSOA area, so that's a low layer super output area, so it's kind of used in a lot of the official statistics, which it's covers the country and it kind of breaks all the regions down into kind of an area of typically about 1,500 people or 660 households, so we can kind of use that lower level of data to kind of map the ONS data to the particular theft items as well, so we could kind of add that additional data there. So taking the data that we had, this allowed us to build up a view of actually to create a base of no thefts, unproven suspicion of thefts and confirmed thefts for each regions. And we were able to get this view to break down across regions, and then as I say, we enriched it with the predictor data. We also had, for each investigation, we had information on the building type, so whether that was commercial, residential, the fuel types, whether that was it was a gas or electricity, and the country as well. The country did have a bit of an impact on it because there were certain data sets that were available for England and Wales versus Scotland as well. From this, we were able to then build up a view of, we could build a data set, an enriched data set across all of the regions then from the LSY level, and we were able to kind of roll that up where we needed to LDZs and GSPs as well. We use this then to build to identify a set of reliable regions, and if we go on to the next slide, please. So our reliable regions, we looked at the actual confirmed theft investigations across the regions, and we looked at consistency across suppliers within that, and identified regions that have a mix of the features which we were confirming through our hypothesis testing that were useful to have in the areas, and we'll cover some that one more in depth in part 2 today. But this enabled us to identify regions that we could use to test, to train and test the model. And so from this, we built actually built 2 predictive models. So we used the reliable regions, so the ones where we had inferred were of good quality investigations, to build first of all a classification model. So this was to identify if theft had occurred or not. And then we built a second model which would quantify how much the volume of energy theft. For clarity, the second model that we built based on the data that we had wasn't as reliable, and so actually we ended up taking an average for those for the estimates for the volumes. But we used the model to classify whether theft had occurred or not at a property. We then trained and tested the model using the reliable regions, and then we rolled it out across the wider population. And this was to get a full view across the whole of Great Britain. We then took that the values that we estimated there, and we did some assurance testing. So this is where we said we took the known unallocated energy, gas and electricity, and we did a comparison to see if we aligned within that, and we'll cover a bit more later on that as well. Can we go to the next slide, please? So as we were understanding the data and speaking to the theft subject matter experts, it was really clear that there was a number of assumptions or kind of anecdotes within the industry, and we wanted to test some of these to actually get an understanding of if these were accurate or not. So we built up a long list of hypotheses, and we worked through them to prioritise these based on actually how useful would they be to the model, and also did we have the data available to actually test them. So the ones here on the screen, we did test. The ones in green came out to be true. So this included things like we were able to look at the suppliers and outcome investigations, and just where suppliers were investigating and how they were investigating based on their lead source to see if they were having if there was different actions, whether some were more proactive or some were more reactive to leads based on the lead source. Others were other ones were looking at how the meter type played a part in investigations. So actually, were there the outcome showed a much higher proportion of investigations where the meter was a prepaid meter versus a credit meter. And we'll step into a couple of these. We've got some more details over the next couple of slides. So we go to the next one. So this one is around potential thefts in remote locations are less likely to have been investigated. So this one, the data was split from England, Wales and Scotland. And here we're showing that for the investigations, there are more investigations in urban areas than there are in rural areas. So the top left chart there, then actually the proportion of confirmed thefts is not quite as skewed. It's a bit more even, slightly skewed in England, Wales, but actually in Scotland, despite the fact you're doing a lot more investigations in urban areas than rural areas, you're actually getting a similar proportion of confirmed thefts in these cases. We go to the next slide. So here we have deprivation indices. So each of these deciles are a similar population, and we show in and the charts are showing that the proportion of confirmed instances of theft per decile. So it's showing that actually there are more confirmed thefts in the high deprivation indices than there are in the lower deprived areas. So we've shown the kind of proportion of confirmed thefts here. The actual investigations was actually slightly more skewed here as well. So there was more investigations taking place in the areas where there's high deprivation. So this is showing that the data is actually confirming some of the kind of the theories that there's more investigations taking place in deprived areas. And it could be that there is more theft there, or it's just that it's known that there's more that is easier to find there, and therefore more investigations occur in those areas. The next one that we will look at is another timely consideration. If we move to the next slide, please. And this is around fuel poverty. So each of the bandings here is a proportion of households in fuel poverty. For this, there is an actual clear difference between residential and commercial investigations. So the light blue is for residential properties, and it shows here the potential confirmed thefts increases as the proportion of households in fuel poverty in those areas. Whereas actually for commercial properties, there's no real increase in confirmed thefts. In the different as the proportion of households in fuel poverty increases. At the very top end, we just say, whereas kind of the 55%, 60% households in fuel poverty, there are much fewer areas with that. So there's kind of a smaller number of cases can skew those kind of very top end results. So kind of it's worth bearing that in mind because it does jump there a little bit at the end. So we use this information from the hypotheses to actually understand whether we should take forward the potential predictors into the model. So in a lot of these cases, we did take the data through, and then we build out a predictive model to classify kind of if there was theft or not across population, and then assign a value for theft. So this brought us to our next to the outcome for the final estimation. We go to the next slide, please. So there's three sets of numbers that we're going to show you here. The first one is the TRAS peak. So as I said, we looked at one of the kind of key data sets we looked at was the TRAS data, because this gave us the confirmed thefts and an actual and true outcomes of investigations. So from this, we were able to identify, okay, what is the current known theft across Great Britain? We had data from when TRAS began, but actually it peaked. It was kind of a consistent level of volume of investigations from about 2018, and it peaked in 2019, and then 2020 the volumes did reduce, and this is obviously, there's an awful lot going on in the world with the COVID restrictions, so that data isn't clearly isn't potentially not a true reflection of kind of what was happening. TRAS stopped early 2021, and there was data then post-TRAS that was submitted for the incentive schemes from September 21. So in 2021, we don't have a good view either. So we used the peak of TRAS at 2019 as our kind of our lower level. And then we looked at the top levels on allocated energy. And this we looked at what the reconciliation of gas and electricity for gas, and we used excess proportion of allocated gas along with the demand for gas from National Grid, excluding shrinkage, to determine kind of the unallocated volumes. We took that back from 2019, April 2019 to March 2020, because we know it takes several years to actually allocate all the gas. We kind of took it as far back as we could from those stats. And for electricity, we had a freedom of information request to Ofgem for electricity losses, and we used that as a average those out to kind of get what's the expected unallocated energy in a year. And so what we expected was our model prediction would lie between that. As Ros pointed out earlier, theft is not the only reason for unallocated energy, so kind of the validation, we wanted to make sure that it's sat between those. If we move on to the next slide, then it kind of gives a view. So this shows that the TRAS peak for gas, we had 117 gigawatts of energy with a unallocated energy of 6,500 gigawatts. Our range sat within that, and it was between 600 and 1,000 gigawatts of energy. The outcome of our model, we did provide a range, and there was also an accuracy kind of level around that, so it was right plus or minus 21%. So even within that, our range for gas was between 500 and just under 1,300 gigawatts for our energy of gas. For electricity, we had 189 gigawatts per hour of electricity confirmed to be stolen through the TRAS investigations, and then the Ofgem kind of outcome was a much larger number, so 130,000 gigawatts per hour, gigawatt hours. So our value of energy theft was between 1,700 and 2,800 gigawatt hours. Again, with a plus and minus 21% there. So this is obviously in kind of the units of energy. We did do a kind of attributed the cost to this using current Ofgem caps, and this range then for 93 million to 155 million for gas, and about 700 million to 1,200 million for electricity. I suppose it's clear to say that this exercise is never going to be a perfect number as data, and as Rose said, as more data becomes available, there will be refinements that can be made to the model and approach. But in the current form, there are some additional limitations just to consider. And we go on to the next slide just to kind of recap on those. So the TRAS data that we based the estimations on, it's fair to say that there was very little validation on the kind of the capture of the information at the start, so there was a bit of noise in the data that we had to work through. The post-TRAS data that we received, there was corruption in it just due to the kind of the format that they were submitted from suppliers, and we didn't use that within the model, but we did use it for some of the hypothesis testing and did exploration. As I mentioned, there were some kind of impacts around kind of the time series of data, so we couldn't perform full time series analysis because of significant events such as COVID restrictions and changing of kind of how the data was captured. So we couldn't do that. We know that there may be further attributes which might be able to apply to particular segments of population. such as kind of the business types that we didn't have access to at this time. And it's fair to say kind of the generic meter data can only predict so far, and more tailored attributes such as kind of tamper indicators or actual readings could lead to much greater confidence in the model. Without the ability to reconcile inputs and outputs at low voltage network, it's not possible to identify theft at a granular level. So reconciliation can only really be completed through this top-down approach that we took at this time. And it's also kind of worth calling out that the TRAS consumption data, so it's the data that has been supplied from suppliers for all properties. This has been used as a base reference for our full population. However, this will exclude those who are not registered on the network. So we know there's a potential gap there for properties that that are connected to the network but aren't registered on the network. And basing the analysis of properties connected to network will miss out any theft that occurs upstream of meters as well.
Great. Thanks, Ursula.
Thanks, Rose.
I shall take us through the next steps. So just have a couple of slides on this if we move to the first of those. So in terms of the next steps for the theft estimation methodology itself, it's been built in an Azure environment, and essentially those calculations are sitting there in that environment and can be rerun with updated data in future years as required. We'll also be publishing a report that's around 85 pages long and sets out the details of the methodology. It's due to be published this week, and I'll send a link to attendees of this session once it's available. And as Ursula mentioned, we can see the potential for the methodology to be enhanced in future years by bringing in additional data that it wasn't possible to do in these calculations. And then if we move to the next slide. In terms of the next steps for theft activities more generally, building on any points you may raise today, in January REPCO will be consulting on its draft forward work plan, be publishing a draft theft reduction strategy, and the final TEM report will be published. In mid-February, REPCO will be publishing its 23-24 budget and 3-year forecast, followed by the 23-24 forward work plan in late March. And then we reach the final box in this slide, where in early April, REPCO will be publishing a final costed theft reduction strategy. And those are the next steps. We're now going to move to the first of our 2 Q&A sessions.
Thanks, Ros. So we've just had one question come in so far via Slido. Just a reminder to anyone who was a bit late joining, you can join Slido by scanning the QR code that's on the top left-hand corner of your screen, or you can type in slido.com into your web browser and type in the number on screen, and that will take you to Slido. So the first question, please repeat the estimated range of values of gas and electricity theft in pounds.
Yeah, absolutely. So for gas, it was 93 million to 155 million. And for electricity, it was 737 million to 1.2 billion.
Ursula, is that based on current
that's
Ofgem pricing?
That's based off the current Ofgem capped prices.
Does anyone have any other questions they'd like to raise? So we had allocated 15 minutes for Q&A. So it seems like I'll just give it a little bit longer, see if any other questions come in.
I can verbally ask one if that's okay.
Yes, go for it.
Is there any indication that suppliers or anyone tries to get that money back by adding it to people's bills? Do you know what I mean? So if we're losing over £1 billion in energy, are those losses accrued back by what's being charged for electricity actually costs more, or gas costs more?
So the unallocated energy has to ultimately be allocated to a metering system. So what you end up with is a reallocation of that gap across the suppliers. So they are effectively picking up the costs of that theft and other pots of unallocated energy, and presumably will need to pass that back to their customers. So yeah, theft costs everyone else money, essentially.
Yeah, that's what I was looking for. Cool, thank you.
We've had a few more questions come in via Slido, so I'll just start at the top. Pleased to see limitations 7 and 8 regarding limited coverage of properties recognised. Seems like a key limitation to any assessment. How will you resolve this?
Sure, Alex, is there anything you'd like to say on this one? I'd probably start by saying that we sought to gather as much data as we could, and then had to create a methodology that optimized use of that data. So we definitely recognise there are limitations, but it's based on what we could obtain.
Thanks, Ros. Oh, was someone just about to speak?
I was just going to say, yeah, I think that's fair to say. I think for some of the limitations at this time, there just isn't the data to be able to do more. I think as further data sources, some of the ones that Ros referred to, become available, things such as the kind of looking at low voltage networks and kind of having more granular level of detail, you'd be able to potentially identify some of those properties that are not registered, but at this time those things are a bit of a gap. I think it's just we have to acknowledge that at the moment.
Thanks both. So next question, to further clarify, was that the wholesale element of the default tariff cap rather than the retail value of the energy?
Yeah, I can say it was the retail value of the energy. So we took the kind of for the domestic and commercial rates and applied them. So that is the kind of the that's yeah, it's not the wholesale, it's the retail value of the energy.
Thank you. Next question, any concerns regarding bias in these estimates given the data sources used?
We have sought, as far as possible, to use data sources that are from they're from standard industry data sets. So we've got the TRAS data, the Crime Stoppers tip-offs data. We did initially start by reaching out to suppliers and looking what data sets they held internally, but we did conclude that we wanted to have data sets that had standardized approaches to gathering the data and weren't from a very small number of organizations, so that we could reduce any bias when we come to extrapolate out using those data sets. So we have sought, insofar as possible, to minimize the risk of bias in the data used.
Perhaps I can just add to that
sorry.
also. I think, yeah, as Ros was saying, like I think with the TRAS data, suppliers were obviously incentivized to report sometimes confirmed theft as opposed to unconfirmed thefts, and that was why we tried to introduce the reliable region approach to try and establish those areas where the results of investigations were mixed rather than being focused more on just reports of confirmed thefts. So yeah, there's certainly some biases, but we did try our best to work around those and make the analysis as fair as possible.
Thank you. So next question, do we get the recording of this presentation? I can answer this one. Yes, you will. So the recording and slides of today's session will be made available on the REC portal next week. It will also be publicised in the weekly bulletin, and hopefully everyone has already signed up to this, but if not, you can send a request to inquiries@recmanager.co.uk to be added to the distribution list for this. So next question after that, do the numbers reflect all levels of engagement across suppliers?
It includes data from all suppliers drawn through standardised data sets like the TRAS data and the post-TRAS confirmed theft. So we have got data covering all suppliers.
Thank you. And how much do these costs equate to per household?
I think that may be a question we'll need to take away because it's not a calculation I believe we've done.
Ros, I did it whilst we were talking. It's between £30 and £50 per household, depending on top and bottom of the range at 28 to 29 million homes.
Thanks, Pete.
Thank you. We've had a suggestion come in, maybe use the land registry and OS data in future to map against MPXN.
I can add that to our list of potential future data sources. Thank you for that suggestion.
Okay. Do you have any estimate of the scale of what we are missing as a result of limitations 7 and 8?
Not at present, because it is an unknown quantity that we couldn't obtain data to quantify. So we, just for those who don't have slides up, so 7 is that the TRAS data excludes networks, excludes MPANs not registered on the network, and we don't have anything relating to theft occurring upstream of the meters. So essentially we couldn't obtain data that would allow us to build that into the methodology. But as Ursula mentioned, at some point in the future, we may be able to get feeder meter data and downstream half-hourly data, and then you can actually see what's happening on individual feeders and identify those instances.
Thanks, Ros. Do we need to consider theft from the network in the methodology to effectively understand the impact of energy theft for the industry?
I would say the more we can produce a rounded figure, the better. We have identified future data sources that would allow us to do that, but we weren't at present able to obtain that data. So we've got the best methodology we can produce based on the data that was available. Oh, sorry, I answered the same question. I think we already had that question, have we? 78. On the publishing of regional results, Ursula, is that one you're able to advise on?
We haven't broken down and breed in full regions. No, we have just report at the top level, because we could only do the validation at that higher level, which is why we've not been able to break it down further.
Thank you. Next question. Are these data sets statistically different from previous data published?
Is the person who asked that question able to confirm what previous data sets they're thinking of? So I'm not entirely sure what that question's referring to, but we can pop it at the bottom, and if the raising individual is able to confirm.
Yeah, so I think if the person who raised that question, if you please feel free to unmute yourself to provide clarification on that. But I think if we move on to the next question for now, is there a way to overlay an environmental impact to the impact of theft? For example, gigawatt hours equals Y CO2 emissions.
It's one we could take away. It's not something we've done, but we could potentially take that one away and look at that.
Thank you. Next question. Comparing to the last estimate, given energy use has increased and cost of energy has increased, does this estimate suggest in relative terms theft has decreased?
Is this so I'm trying to think. So we had is this the Ofgem estimate? Is it the 400 million from about 10 years ago? I think I'm not entirely sure I can answer that one. I'd need to know what it's comparing it to, and the volumes associated with the previous one. I'm not quite sure I can say that.
We can take that question away as well. That's absolutely fine. So moving on, can we get a list of all your acronyms and their meanings, please?
Absolutely. In the report, there'll be a glossary section with all the acronyms. So yes, we can include that.
Wonderful, thank you. Is it possible to calculate what the cost of theft adds to on a domestic bill?
Pete's calculated that. Was it that one was £30? Was it, Pete?
Yeah, between £30 and £50, depending on top or bottom of range.
Thank you. Then next question. How many incidents of energy theft does this break down into? For example, 636 gigawatt hours of gas theft equals X cases of gas theft reported.
That's just going up.
Yeah, sorry, I don't have that to hand, but it is in the full report. We've got the breakdown of kind of the confirmed cases within that. So apologies, I don't have it to hand just now, but we will be able to share that through the report.
Yeah, we'll take all these questions away and we can confirm the ones that we've not been able to answer today after the event. And then confirmation, it's the off-gem figure. So we need to know the megawatt hour associated with that, because I think it was a financial value at the time, which I don't think we've been able to establish, but I will take that one away as well, and see if we can compare it to that previous figure, provide that information after the event.
Thank you very much. We haven't had any further questions as of yet, so if you like, we could move on to the next section. Yeah, okay, I will move on.
Thanks. Just as a reminder, and for those who joined late, this second section is a deep dive into the methodology. So covering topics such as random forest algorithms, multivariate analysis, and decision trees. So this section is entirely optional, as we understand that not all of you may want that level of detail. So feel free to drop off if you'd like, but I'll pass it on to Ursula now that will take us through the deep dive of the methodology.
Thank you, JP. So in this section, we're going to kind of cover, as JP says, we're going to go a little bit more into the detail of the modelling that we carried out. So we'll kind of step through kind of the data that we acquired, how we linked the data sources together, some more details about the quality of the data that we accessed, and then into the model development, kind of how we the pre-processing around that, how we set up the model, and then how we trained and tested it, and then how we kind of applied that model to the to create the predictions, and a little bit more detail just on kind of that assurance level that we did, the validation at the end. So we go on to the next slide, please. So this kind of so we had it before. So this is the data that we were able to access and we kind of used to build our estimate. So the experience data is kind of the TRAS data, so the theft risk assessment data. So this was all of the investigations, their outcomes, and the updates from them, and kind of then we were able to classify them as kind of what was confirmed theft, what was unproven suspicion. There were some other kind of categories as well, and then there was the confirmed no thefts as well. We also had some of the XServe data, so looking kind of the reconciliation by month, data from there, and then for electricity, for the Alexon, kind of looking at some of their the metered volume data at GSP level. So we were looking at that initially to kind of see if we could do some of the confirmed unallocated energy at low level, and we were looking initially to kind of could we split that into the technical losses, non-technical losses and things, to do the comparisons of where to kind of lower that potential pot of what theft could be. In addition, we had some from Crime Stoppers with reports on energy theft. So that was kind of just from one specific lead. And a lot of those investigations then were also fed through in the TRAS data as well. Then we looked to the Office for National Statistics for the predictor data, so this is around kind of the deprivation data, crime data, so kind of non-energy theft crimes that may be a useful indicator as prediction, fuel poverty levels in areas, the rural-urban classifications, with population densities, and housing as well, the makeup of housing within it. And then we looked at the spatial data as well to be able to tie these things together. There were some further sources identified within this, but they weren't able to be accessed as we went through this. And as I mentioned before, the kind of elements that we may have indicated being useful for particular segments of population, but such as kind of the business classification for commercial consumers. And there was a kind of theory of kind of some published hygiene data for food outlets, but we weren't able to kind of access the data at this time. So if we go on to the next slide, then we'll kind of show how all this data linked together. So the TRAS data and supply data, so kind of from that we had kind of their meter readings, the suspected thefts, and we were able to get the meter points from that, and therefore we were able to have information around the meter and the account type. That's whether it was gas, electricity, or whether it's commercial and residential. From the meter point, we were then able to obviously allocate that to the LSOA, so we knew what region it was in, and then from that we could then tie together the additional predictive data. So the ones in green to population, rural, urban, housing, deprivation, and fuel poverty. We were then able to tie the LSOAs to further spatial data, so the LDZs and GSPs and the suppliers, and then there was some additional data. So the crime data was actually at a police force level, so we had to map through different levels of spatial data just to get that connection and get that allocation to each of the kind of the allocated to kind of meter points. If we go on to the next slide, so we needed to get an understanding of the quality of the data as well as kind of building some insight to determine kind of that we were building the right model. So this included kind of the data preparation and scoping. So this was around cleaning the data, running summary statistics, identifying valid missing values, so that was both to kind of understand where data wasn't quite right, but also kind of just kind of getting a feel for what that data looked like over time and kind of what sort of things it was containing. This was also the linking of the data, so working through how we actually map some of those data points together, so figuring out kind of where the spatial data linked up and making sure that we could work through any challenges there in formatting and things like that. So there was quite a lot of preparation of the data. But what that meant was then we had a consolidated data set ready for analysis. We had some summary statistics kind of to give an overview of kind of what the data was telling us. And we had identified kind of some of the subsets that were required to kind of run the models, which we'll go through in a bit. But we also did some exploratory analysis. So this was understanding kind of the limitations data, some statistical summaries, and we did quite a lot of visualization of the data as well. Within this, this is where we carried out our hypothesis testing. So we had, as I mentioned before, we had identified kind of a long list of hypotheses. So we wanted to kind of work through them to see which ones, to get insights from the data to kind of actually validate whether some of these assumptions were accurate or not, and also kind of to make sure that we were including key predictor data if it was demonstrating kind of strong correlations within that. We then went on to kind of to build a prediction model. So this was for this, we're kind of segmenting the theft incidents by outcomes, kind of that's the confirmed thefts, the confirmed no thefts, but also the unproven suspicion of thefts as well, because we understood those to be likely to be theft, but just not having the kind of the the right evidence to support that. We then look to model the losses as well, and analyse the different impacts of the variables on theft. And then once we kind of had built the model, so we, the prediction model kind of understanding what went into it, and then also kind of looking at the performance of the models and the model evaluation, we're then able to apply the models and extrapolate out against the population. As I mentioned earlier, and we'll come to it as well, there's two models that we had built, and actually only the classification one that we took forward, and we had to kind of change the approach for estimating the value of theft. If we go through to the next slide, please. So this is around the model development. So this is kind of just a high level view of the predictive model. So as I said, with the first model, we had 3 outcomes that we were training it for. We took a reliable regions, come a bit more into those in a second. So we took data from the reliable regions and we split that into an 80-20%. So we used 80% of the data from that to train the model, to build the classification model, and then we tested that on the remaining 20% of that region, to check its accuracy and its reliability. And then we took that the model and we applied it in our prediction data set. We then took the confirmed theft from that, and we trained our second model. The second model was around predicting the assessed losses. So we again used 80-20% split, and we trained the model and we tested it. And it's in this one that we discovered that the kind of the parameters that we had were not reliable for that. To be able to apply that across the prediction data set. If we both these models kind of were built using known outcomes, so they both fall into the category of supervised machine learning. As such, these models serve different purposes. Their general structure was actually very similar. If we go on to the next slide, please. So within the pre-processing, so for setting up the models, we identified that actually we weren't able to just build one model. Through kind of working with the data, there was obviously very clear different energy types of gas, electricity, the property uses, so residential, commercial, there was kind of clear differences coming out through those with the in the hypothesis testing for some of the aspects, and also just the available data that we had. Some of the data types and descriptions were slightly different for Scotland than they were for England and Wales, so we had to kind of separate them out. So kind of we ended up with 12 scenarios that we were running through the model to train. From that, we also had to then work to what were the reliable regions. We defined these at a grid supply point with the aim to capture, and we separated them for England and Wales, and we were able to do one for gas and one for electricity, and then Scotland, because we had trained the model for Scotland using the Scottish data, we actually just went for, we used all of the data available both regions within that to train and test before we applied it to the wider population. The criteria that we kind of followed, it was looking at the conversion rates of suspected investigations, confirmed cases, to make sure that there was consistency, because see around the conversion rates were across multiple suppliers, so it wasn't just very dominated by a particular supplier doing things in a particular way. We want to make sure that those regions had that similarity. There's also a good balance of kind of the urban rural geographies, and some of the other predictions. We want to make sure we've captured mix of deprivation areas as well, and also that we had comparatively few under investigation cases as well was another factor within that. The use of reliable regions was applied to the classification model only. For the estimates, we used the full population to build that up. Because we were only using obviously the confirmed theft, we wanted to get a wider population as we could to build that. Okay, we'll go on to the next slide. So the next setup was around how we actually set the model up. So a lot of the data sets and variables we were working with categorical variables, so we had to convert them into numeric type. And that was necessary kind of to enable the machine learning algorithm to help it to enable it to ingest the data. And then, as I mentioned, kind of we did a randomly split the reliable regions into kind of a training data set and a test data set, and we use an 80-20 split for that. We go on to the next slide, please. So we've mentioned in passing, so the algorithm that we selected to use was a random forest algorithm. In summary, kind of it builds up multiple classification regression decision trees, and each of which predict an outcome based on the subset of the full training data set. And then the final result takes an average of all of those kind of particular trees that is built up. Some of the kind of the key benefits and limitations of kind of this. So one of the key benefits is it was viewed to have a higher level of accuracy compared to some other machine learning algorithms, and there was a lower risk of overfitting the model as well. There was also a robustness to outliers. We knew there were some valid outliers within the model, so it had a bit more robustness to that, and it could handle a large number of predictors as well. It was also efficient when running on large data sets, which we're working with here. And you had the ability then to kind of to alter some of the parameters of it to kind of to get a better view and a better outcome. Some of the limitations of it, there obviously is a bit of reduced transparency of kind of how the model uses some of the predictors because they're being averaged out across multiple trees, decision trees. And there's an inability to kind of extract the significance of each particular factor since that varies across the decision trees. But on the whole, it was deemed to be kind of the most appropriate algorithm to use in this case. We go on to the next slide, please. So when we were we trained the model, and then I say we kind of used that 20% sample to kind of to test the model as well. And then to assess that, we were looking at some of the statistical outputs from it. Within this, we were looking at for the classification model, so that was the first one to determine whether it was theft, unproven suspicion, or no theft. And we carried this out across each of the kind of the 12 scenarios. And the kind of the key measure of this is what's known as an accuracy score. So this is the table on the right here, the kind of the matrix. What it does is it assigns the actual outcome to the predicted outcome, and gives a proportion for each of those. And the accuracy score is the summation of each of the kind of the correctly predicted outcomes. So our model across the different scenarios performed reasonably well. It had accuracy ranges from 68 to 93%. So averaged about 79% across those. So that deemed to be kind of a reasonable outcome for this type of model. Our second model was the regression model to predict the value of the theft. For this, we've looked at three different statistical measures. So R squared, which is a measure, statistical measure the fit that indicates how much variation of the volumes of energy theft are explained by the predictor volumes or predictor variables. A value of 1 indicates the model's perfect. Perfect explains the variation, and 0 indicates that the model is no better than taking a mean average. And I'd say we actually had some negative scores here as well. So it did not perform very well. The mean squared estimate is the average of the squared difference between estimated and actual value of energy theft, and you'd want a lower value there. And the root square of the MSE is also widely considered like an excellent general purpose error metric for numerical predictions, and a lower value indicates a better performing model, and we had kind of slightly higher values here. So on the whole, we did not view this to be a good model, and so therefore we didn't carry it through on the predictions, as kind of an average within each of the value within each scenarios was seen to be a better accuracy. So we go through to the next slide, please. So then once we trained the model, so the classification model, we had to apply the predictions. Due to the full scale data set, we actually took a 5% extract of the full Great Britain set to apply the predictions. And that was a kind of a weighted sample to make sure it had full representation there across the different regions. And so we applied the model to that 5%. We then converted it to a volume using kind of the averages, and then we extrapolated that up to the full kind of to the wider GB population. Because of the way that we had used the predictive data from TRAS, we had more than a year's worth of outcomes within that. But we knew that not all of the thefts would occur within the same year, so we took an annualization approach to it. The TRAS data was over 7 years, but we knew actually a lot of that data was like only really occurred within 3 to 4 years. So we actually did an annualization of kind of 1 to 7 years, and then took I think it was a 3 to 5 year range within that to get our range. And then, as I kind of mentioned before, we used the current cap prices to convert that into a retail cost as well. If you go to the next slide, please. And as I mentioned before, kind of so a bit more detail here on kind of the assurance then. So we wanted to kind of test did our outputs sit within a valid range. For gas, we took the national grid demand minus shrinkage, and used the XServe kind of unallocated in reconciliation proportion to come up with how much unallocated gas is there within a year. And for electricity, we took the data provided by Ofgem on a freedom of information request for annual losses, and took an average of that for our electricity losses. And I believe that is us on to then questions.
Thank you. Yes, we've well, it's more of a statement than a question. So Phil Price has said, "Thank you. Very helpful to getting support at the sharp end of conducting RP customer visits to ensure metering points are safe / energy is not being stolen." Just a reminder for anyone who was late joining us today, you can join Slido via the QR code on screen or typing the number that's on screen on the left-hand side into slido.com, and you can raise your questions that way. So we're not getting any further questions come in at the moment, so I think we can move on. Okay, so that's the end of the session. Thank you to everyone for joining us today. So just a final bit from me. We have set up a survey in Slido, so you can let us know how you felt the session went. Any feedback is greatly appreciated. You can give us comments and also let us know how useful you thought the session was. And thank you again, and I hope you all have a good day.
Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.